So hi, hello everyone. I hope I'm audible. All right. This is your educator, your tutor, your friend Sanjay Vishwakarma. I welcome you all to yet another session of V-Learning. So now V-Learning is a platform which focuses on providing right to quality education for one and all. Okay, just like, share and subscribe to our channel. Click on the bell icon so that you do not miss any regular update. Share it with all your friends, family and relatives so that someone out there can get access to quality education. All right, without any delay, let's get started with today's session. Today, remember what we are going to do? Electric generator, right? Electric generator. In the last session, we studied a very beautiful phenomenon, electromagnetic induction. Based on that phenomenon, there is a device. We are going to study this. Okay, before that, have you seen this? Have you seen this? What is this? While traveling in train, maybe you might have seen, right? While going somewhere in the fields only, the bigger fields, you might have seen this, correct? This is basically a wind turbine. This is basically a wind turbine. What is this used for? What do you think? What is this used for? This is basically used to generate electricity. Generate electricity, yes. Right? Now, this particular thing, today we will be learning how actually, what is there inside this which is generating electricity? What is there inside this which is generating electricity? Electric generator we are going to study. So from the name only it suggests something which generates electricity, right? Electric generator. Something which generates electricity. So you can write the definition. An electric generator is a device which converts mechanical energy into electrical energy. If you see this particular thing, what happens is when wind comes, wind blows, all right? When the wind blows, this fan starts moving. When the wind blows, this fan starts moving. This movement is mechanical energy, right? And some circuit is there inside it which converts that mechanical energy into electrical energy. That's how the electricity is generated. Clear? Wind will be blowing like this. Because of the shape of the blade, it will start rotating, right? Rotating means mechanical energy, correct? Now there is some circuit inside it which converts that mechanical energy into electrical energy. That's how we get electricity from it. Fine? Note this down. And on which principle it is based? Electromagnetic induction. This is very important. In exam, many a times they ask, in which principle does electric generator based on? So electric generator works on the principle of electromagnetic induction, in which when a straight conductor moves in a magnetic field, then the current is induced in the conductor. When a straight conductor moves in a magnetic field, the current is induced in the conductor. Clear? All right. Do you remember electric motor? Last to last session we did, right? It is something like this. The battery is connected. When the current flows, it starts rotating, right? These split rings are there to reverse the polarity so that it rotates in the same direction. Otherwise, it will do half-half, right? Now, electric generator is the reverse of electric motor. In the last session only, we understood electromagnetic induction is a reverse process. Normally, we connect a battery, magnetic field is generated, produced, right? Due to current carrying conductor. But in electromagnetic induction, what happens? When we pass magnetic field through a circuit, current is generated. Opposite, when we pass magnetic field through a circuit, current is generated. The same way, electric generator is opposite of electric motor. What happens in electric motor? We pass current, then it starts rotating. Electrical energy is converted into mechanical energy. Remember? Electric motor, electrical energy is converted into mechanical energy. But electric generator, when we will rotate this, current will be generated in this. Opposite, when we will rotate this, current will be generated in the circuit. So in electric generator, what I'll do is, if I remove this battery, because I have to generate current, right? If I remove this battery and put a galvanometer, or you can put a bulb also here, you can put a television also here, whatever you want to put. So now I have just put a galvanometer to check whether current is generated or not. So what happens, this particular setup, when we start rotating this, then the current starts generating. We will study this in detail today. Okay, this I just wanted to tell you, it is just opposite of motor. There electrical energy is changed into mechanical energy. Here in generator, mechanical energy is changed into electrical energy. You might have seen there are generators in buildings, right? If you go in any marriage party, you will see green color generator thing is there, right? They rotate it with hand, with the handle, correct? And the electricity is generated. So electric generator generates electricity. That rotating thing from hand is nothing but mechanical energy. We are providing mechanical energy, right? Now, before getting deep into the topic, let's understand the very basic. Suppose there is a magnetic field flowing like this. All right. In electromagnetic induction, we understood one thing, that current is induced only when there is a changing magnetic field, right? Current is induced only when there is a changing magnetic field. Now for changing magnetic field, there is a way, either you take the magnet and put it inside, then outside, then inside, then outside, then inside, then outside. Now whole day you cannot hold the magnet and do this, right? We have to make the process automated. So now just understand, there is one more way of having the changing magnetic field. Fine. Suppose this is a loop. This is a conducting loop. Magnetic field is passed. Fine. How many magnetic field lines can you see? In 12th standard, we'll talk about this as as magnetic flux. Right now, we cannot use the word flux because it's not there in your course. So I'm just telling you to count the number of magnetic field lines. How many? 1, 2, 3, 4, 5, 6, 7, 8. 8 lines are there inside it, right? 1, 2, 3, 4, 5, 6. Sorry, 7 lines are there inside it. Correct? Now, if I start rotating this, if I start rotating this like this, first of all, this is a 3D. This is going like this, magnetic field. This loop is kept like this. Magnetic field is flowing like this. The loop is kept like this. All right. Now this loop is like this, but I will be rotating it like this. Clear? The loop is like this. I will be rotating it like this. Fine. Now if I start rotating it like this, it will be like this. Now how many magnetic field lines are passing from inside? 1, 2, 3, 4, 5. First it was 7, then it is 5. I am rotating this, I am showing slowly. Then again I rotate it more. 1, 2, 3. 3 lines are passing. Now 0 lines are passing, not 1. This loop was like this, right? I am rotating it in this way. So now it is horizontal. Magnetic field lines are also like this. This loop is also horizontal, like this. So from inside the loop, nothing is passing. Correct? This is like this. If something is going from here, it will pass. But if we'll start rotating the loop like this, when it will become horizontal, the lines are also horizontal. The loop is also like this. Right? It is flat. Nothing is passing from inside. Correct? Again, 0 lines. Now 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Right? So like this, what is happening is, magnetic field was initially, there were 7 lines passing. Correct? Then 5, then 3, then 0, 3, 5, 7. Then again 5, 3, 0, then 3, 5, 7. So it is decreasing, then increasing, then decreasing, then increasing, right? That means if we take a circular loop and start rotating it in the magnetic field, we will get a changing magnetic field. We don't have to take the magnet and put it inside, outside like we did last time to explain you the concept. Another way to have a changing magnetic field is, in the continuous magnetic field, suppose here I have put a north pole, here there is a south pole. Alright, I have kept magnets like this, or let's suppose I have kept a horseshoe magnet like this. So I have a continuous magnetic field. Inside this magnetic field, if I take a armature coil or a circular coil, anything, find a loop, and if I start rotating it like this, I will get a changing magnetic field. Got the point? Understood? Now this particular thing we are going to use in electric generators. So first of all, there are two types of electric generators. Again, this is important. AC generator and DC generator. AC generator and DC generator. Both generate current. The difference is AC means alternating current. Alternating current. And DC means direct current. Alright. So alternating current means for half loop, the direction of current will be different, and for half loop, the direction of current will be different. Okay. So every half loop, the direction of current will change. Every time. In one complete loop, the direction of current will change 2 times. Okay. DC means the direction of current remains same throughout. Direct current, the direction of current change remains same throughout. Okay, from the name only you can understand. Alternating current, direct current. Clear? Let's understand. Now this is an AC generator. Okay. Now the setup, design, everything is same, only there is a small difference in DC and AC is here. Now see, first of all, there is north and south pole. We are having a continuous magnetic field. That's what we want, right? Now this continuous magnetic field is there, this flow is there, and we have kept a coil, a circular or a rectangular loop. A loop is there. Fine. This loop will rotate like this. So the magnetic field will be changing continuously, because of which there will be a current induced in this coil, which current will flow in the circuit and electricity is generated. So simple, right? So now understand what happens. First of all, these things are slip rings. Make this diagram and note it down, or just listen. I'll give you time to write down. Fine. So now this is armature coil. Okay, the same as it was in electric motor. Don't be confused in motor and generator. That is converting electrical energy into mechanical energy, and this is converting mechanical energy into electrical energy. From the name only, it is generator, generating energy. Fine. Generating current. Now, so this is a continuous magnetic field, north pole, south pole. This is armature. These two are slip rings. There we use slit rings. These are slip rings. Okay, everything is same. Armature coil is same. This brushes is same. Then north pole, south pole is same. The magnetic field flow is same. Only this thing is changed, that is slip rings. So in AC, we use slip rings. Why do we use this? Understand. Now suppose I start moving this coil in this direction. Okay, anti-clockwise. Fine. Now when I am moving this in anti-clockwise direction, what is happening? I hope you understood the diagram. I'll explain you in this way. I've kept another figure so that I can explain you properly. Suppose this is there. Fine. If I start moving it like this, right now it is horizontal, A, B, C, D. You can see this is the armature coil. If I start rotating, this axle is big, handle is there, I start rotating. This kind of generators you have seen, they start rotating with the handle, right? So I'm rotating it. This will rotate. The magnetic field is like this. While rotating, just now we understood that when the loop in the magnetic field is rotated, then the magnetic field changes continuously, increasing, decreasing, increasing, decreasing, increasing, decreasing, right? So because of which the current will start generating. I'll just remove these lines so that you can see. The current will start generating. It will start flowing. Fine. If I start rotating this, the current will start flowing. Now what happens in this half way? When it is rotated like from here to here, the magnetic field will decrease then increase, correct? See, let's understand. When I am rotating it like this, okay, initially what will happen? Right now the magnetic field line passing inside this loop is 0 because they are like this. They are not like this. Fine. The loop is opened in this way. If I start rotating it, magnetic field lines will start increasing. Magnetic field lines will start increasing. North pole is this side. Now if north pole, and that too increasing means it is coming near, we can assume that way. Magnetic field lines are increasing, that means we can assume north pole is coming near. Correct? If it is coming near, it has to, this face should be a north pole because it opposes the change. This face, when I'm doing it like this, understand? All right. Understand in this one. Now, after rotating this, it will become like this. First of all, it is horizontal. After rotating it, it will become like this. Vertical, right? So now, in this process, from here to vertical, magnetic field lines increased, right? Direction of current, since north pole is there, magnetic field is increasing, we can assume north pole is coming near. And according to Lenz's law, what we understood, that the current direction is in such a way that it opposes the cause. So that means the north pole will come towards that side of this face. And here, south pole will come towards this face. I hope you are getting. A north pole will come towards that side and a south face will come towards this side. Correct? South face this side means the current will be flowing in this direction. Getting? Here also, okay, the direction of current I'll just make. It will be in this direction. Okay? For first half. But again for another half, what will happen? For another half, what will happen? The direction of current will change. Okay? Alright? I hope you remember that point where I told after every half rotation, we have to change the polarity to maintain the direction of current. Remember, we have to change the polarity to maintain the direction of current. Here, since the polarity is not changing, why? Because we are not using split rings, we are using slip rings. What is slip rings? This part of the wire is connected to this ring. Okay? These are not half-half, one complete ring it is. And this part of the wire is connected to this ring. What happens is, this will rotate like this. Now, if we will not connect this, it will entangle, right? To prevent it from entangling, we have connected these axles, these slip rings. Fine. So, this slip ring will rotate. And this slip ring is throughout, this wire is throughout connected with this side. And this wire is throughout connected with this side, right? If it will rotate also, suppose it rotates, fine. See this diagram. It rotated. Now this wire, it came here, but this brush is still connected to the same slip ring. This brush is still connected to the same slip ring, and here also this brush will be connected to same slip ring. So this slip ring will be touching this brush here also. And this wire is permanently connected to this slip ring. This side of the wire is permanently connected to the slip ring. Got it? So when this will rotate like this, suppose, this part of the wire will be rotating like this. So throughout it is connected here only. And this part of the wire will be rotating like this. Throughout this is connected here. Clear? In the split ring, what used to happen? After half rotation, this side of the wire used to get connected with this one. And this wire used to get connected with this one. That's the reason the direction of current was maintained in this loop. Here, since it is not happening, the direction of current will change after half. Got the point? Right now it is going from north to south. Then this will rotate from south to north, right? Opposite. Because of which the direction of current will reverse. All right? Okay. See. It is rotating in same direction. But see the direction of current. First it is like this, then like this. In this loop, this circular, in this circuit. If you see the armature coil, it is continuously rotating like this. But if you see the direction of current, the yellow thing which is moving, first it is going like this, then this, then this, then this, then this, then this. See the galvanometer. So if this is moving in the same direction continuously, and these are slip rings, if it is connected to slip rings, see how this slip ring is moving? Getting the point? So it is actually preventing this armature coil to get entangled like this. It will keep it like this. Fine, the two ends always like this, like this, like this. Clear? Easy? I hope you got this. The only concept is what you have to keep in mind: whenever there is a coil in a magnetic field, on rotating that coil, magnetic field changes continuously. That thing we are using here, that we'll rotate the coil, this magnetic field will change continuously in this particular circuit, and the current will be generated, current will be induced. Okay, continuously the current will be there, it won't stop. Fine. Now DC generator. What is DC generator? The same electric motor circuit I told, remove the battery, connect a galvanometer. Rest everything is same. Here the split rings will be there. In AC generator, split rings are not there. In DC generator, the split rings are there. Okay. So what will happen? The same thing. If suppose I start rotating it like this, after half rotation, now the current in the circuit, suppose it comes like this. All right. After half rotation, it will go from south to north. Right now it is going from north to south, then south to north, right? Correct? Now the direction of current will change, right? But here why it will not change? Because the split rings, first it is connected to this side of the part. This is permanently connected to one split ring. This is permanently connected to this split ring. Now while this is rotating, after some time this split ring will be connected to this part of the wire. Right now R1 is connected to B1, correct? R2 is connected to B2. After half rotation, this R2 will be connected to B1. And this R1 will go and connect to B2. The polarity will change, right? Since the polarity will change, the direction of current in the circuit will remain the same. Because in this the direction of current will change. The moment in this in this armature coil, the direction of current will keep on changing. But since here this is our main circuit which will be giving us electricity, right? So here the moment it will change, here the polarity here will be reversed. The moment the current will be reversed here, the polarity will be reversed here also. So reverse, it will be in the same direction in this. Understood? Went bouncer? Okay, let me make you understand in a much better way. Let's understand it again. Fine. Split ring, what happens? This part is connected to this throughout. This one is connected to this throughout. Okay. Right now the direction of current in armature coil is clockwise, let's say. Okay. After half rotation, what will happen? When this AB will come this side, the CD will reach this side. Then it will start moving from south to north after half rotation. Okay. That means when it will start moving from south to north, the direction in this armature coil. So right now the entire current is like this, right? See. After half rotation, what will happen? The direction in the armature coil will change. It will be like this. Fine. But this split ring will come this side. See, when the direction of current will change, this split ring will become this split ring will become this. I hope you are getting the point. So just because the split rings are changing, the polarity will change. That means here the current will be same. Got the point? Here it will change. Here this will adjust it and the direction of current will be same. So this is DC generator. This is DC generator. So there is only one difference in AC generator and DC generator. There the direction of current changes after every half rotation. Here the direction of current remains same. Why? Because there we use slip rings, here we use slit rings. Okay. Normally, generally AC generator is used more because we use AC current. In our household we are using AC currents. Majorly or majorly everywhere AC current is used. Why? More efficient it is. Okay. It takes less power compared to DC. Okay. So just see this. It will be rotating. This red one, first it was touching this side of the wire. Then after some time this red one will touch this side of the wire. Getting? This red one is now touching this side of the wire. When it will start rotating, it will come this. So first touching this, then this, then this, then this. The polarity is reversing every single time, because of which the current in this circuit is maintained. Because here after every half cycle the current direction is changed. To maintain here we have to change this polarity also. Understood? Alright. So in this session I hope you understood what electric generator is. If you remember the first diagram, that windmill, right? The wind turbine. So these are the devices with which we generate electricity in a very broad way. Either you can take wind turbine or water turbine. The big dams are made, right? Through those dams, the water is being thrown on the turbines which are there down. Okay, when the water goes on those turbines, they start rotating. Because of the rotation, the current is induced and the electricity is generated. Now you know how why big dams are being made, and they are telling this is electricity plant or something. Fine, hydroelectricity. Or this is wind, because of wind the electricity comes. So when wind goes, the windmill rotates. When it rotates, the armature coil behind it also starts rotating, current is generated. In water turbine what happens, or in hydroelectricity what happens? The water from the dam, it goes on the turbine. Because of the pressure, the blade starts moving. That fan, that turbine starts rotating. The coil which is attached behind, it also starts rotating. And because of which electricity is generated, because they are kept in a constant magnetic field, continuous magnetic field. Okay. In the next session, we'll be seeing domestic electric circuits. Till then, keep learning from We Learning. All the best.